After, yes, afternoon, Lamari, afternoon. All right, I just posted notes on what we're doing today. Just posted it. Lamari, you can shout Tivon, so we can start. Jaden, you shout Israel, and Tristan, you hear from Antoine, Aman, or Orville. All right. Okay. All right, we're gonna start. They're probably gonna join in a little bit late, because I want to catch the supermarket. It close at 6, so we're gonna try finish by 5:30 today. Um, yeah. So we'll have to start now. So today, what we're going to be doing is we're going to be doing random variables, and we're going to be doing binomial distribution. So I would have just uploaded the notes, probability distribution and binomial distribution. I don't know if anybody see the joke in uploading the notes, but I use the symbol. So the symbol, I use the and symbol in reasoning and logics. That's fun, right? Oh no, instead of putting the word and, I use the reasoning and logic symbol. Oh, so in the notes, if you look in the classroom how I upload the notes. No, not in the notes, but the title for it. I use a little ant symbol. Yeah, it was supposed to be, you know, supposed to be fun, but yeah. Well, some persons might not, you know, might not too penny, but ready now. So, oh, by the way, I don't know if you realized the merit listing is out, and we want to big up Orville, who placed third in Jamaica in pure mathematics. And Orville forward, we have to big him up again still. Orville placed third in Jamaica in pure maths, right, which is excellent. Unfortunately, Jaden, we didn't get any ad math placements, but don't worry. This year we're gonna replicate what Orville did in Unit One, right? Going for it. And applied math. Surprisingly, the results for applied math was extremely poor. Applied math, meaning tools were in the top 10. Yeah, tools were in the top 10. I'm gonna open it so you can see. Yeah, I guess I can start off with looking at this. Them rob you, oh, them rob you. How much did they want release? No, you know, his last year was the only year they released top 100. Usually they only release top 10. Yeah, usually they only release top 10. No, top 100 is just a one-time thing. Yeah. We're opening it now so we can see it. Um, see it here, see it here, applied math, 2. 4 is in the, exactly, exactly. Because as I tell you, Jaden, many persons are doing applied math, not going to any class, not seeing any past paper, them just go in the exam and do it. So when they go in the exam, they're like, it's easy, but they could have done better because, number one, not many schools do applied math, and even if they do register to do applied math, maybe they're not being taught the contents. So if you notice, nobody in Jamaica gets a distinction, which show you how bad applied math is. Yeah, 4. Easily, easily. All of us should be placing easily. That's why I said just come class, all of we get 1, and we'll just fill out the top 10, 1 to 10. And that would be great for ourselves, it would be great for our school. Trust me, any type of merit listing, gonna do you a great deal. You look at now applied unit, well that's unit 1. Scroll way around to you. I don't want to look at unit 2 yet, since we're doing unit 1. And unit 2 was worse than unit 1. So we all of us can place. That was applied. I want to go to pure. I want to go to pure mathematics. So pure mathematics. See it here, Orville Daily third. Orville came third in Jamaica. Two Campion guy beat him. It's always Campion at 1 and 2. We want to upset that now. Right? Campion always have somebody at first. So Orville plays first, and that's it. Tristan, you know Khalil Martin? Yeah. He mop you up, man, Tristan. Oh. Physics, Orville was there again, but not in the top 10 this time, was at 13. So maths was good, physics down at 13, but nobody else is really there, right? So we have some work to do. Cause if you look at it, look at them thing here. Arden, Cornwall, Campion, Immaculate, them school they dominate. So we have to do something about this year. We can't, gentlemen, we're too bright for not dominate them thing here. Dollar Mario? Yeah, we can have Cornwall and Campion and Titchfield and Campion and Rossies and Immaculate, and it's the same school them over and over dominate. PE, Arden, and same set of school. Oh, Courtney, big up Courtney. Courtney placed in B Med. Thinking place 7th. I forgot to unit 1 B Med. Here it is, B Med. Courtney place 7th. Here it is, Courtney Reynolds 7th. Joel came second. And I think Avandre came 17th. Yeah, Avandre came 17th. But we have some work to do. I only count top 10 as placement. 11 going down is not a placement. It's there, it's noticed, but top 10 is a placement. So we have some work to do, and I know we can do it. So this year for sure, Jaden, Afinai top 10, Lamar, Afinai trust top 10. Tristan, we need Finai top 10, don't it? We need Finai top 10. So ready. So now we're gonna start with the topic for today. And the topic for today is probability distribution. Tristan, what are you watching on TV? Alright, so we're looking at probability distribution, and first we have to talk about random variables. Now, we already have an idea of what random variable is. What? Top limit reach, tab limit reach, uh, close all tabs or upgrade. Okay, let me just go and close some old tabs. Because I can't upgrade from this already. I already paying for this tool. So I don't know why they want me to upgrade. Alright, it's having some, I don't know why it's doing this. So I'm going to just switch over to Microsoft Edge. Alright, ready, let's go. So now finally I get to share what I want to. The probability distribution. So I'm not sure what's going on with Zodo, but we're gonna go through probability distribution. So of course, the notes are here, but we're just gonna go through the main points of it. So I want us to consider a scenario before we can understand the idea of distribution, right? So whole heap of time we get question and we see this whole heap of table and we hear if set it equal 1 and all of these crazy stuff. Why do we do that? So the example I want to zoom in on is let's look at the coin. It's always easy to start with the most simplest example. Before we look at looking at defective television set, before we go to look at bacteria growth, before we look at any of those stuff, it's always easier to start with the simplest one. So Jaden take out a coin and Jaden take out two coins rather and him flip it, right? It's either Jaden can get what? Two tails or him can get a head and a tail or him can get two heads. Then maybe Lamario want to summarize by saying, let's look at the probability now that Jaden would have gotten either no heads, one head, or two head. Realize the probability of Jaden getting no head would be at the top it work out here. That meaning get tail tail. So no head is a quarter. Working out the probability that Jaden get at least one head on either one of the coins is a half. Working out the probability that him get two heads, meaning on both coins would also be a quarter. So we notice that when we add up everything down at the bottom here, the sum of the probability equal 1, right? Now, what we then do is define the number of heads. We'll notice that this is what? Discrete. Why is it discrete? Because it's countable. It is what? Number of heads can either be 0, 1, 2, 3, 4, finite values. So this is our discrete random variable number of heads. We can call it y now. So let y denote the number of heads that appear. So y is the random variable. In that case now, we'd rewrite the table as number of heads represent y, and this is now the probability of capital Y equal common y. Meaning down here, so now we're finding out the probability of us getting that certain expected number of heads. That is all. Alright? That is all for discrete random variables. That's the definition of discrete random variables. It's what? Discrete random variables. It is countable and also its distribution, the sum of the probability must adds up to be 1. That is all. Right? So here's some question now to, how they might word up discrete random variables. So Tristan, read this question for us, please. Very good. Now you see this part, very powerful. Illustrate the probability distribution on a diagram. So if you're looking through the syllabus, you'll notice something what they call CDF. and something that they call PDF. We're going to learn how to draw both of those. All right, so just going back, let me share the tab here. So if we go to the notes, the diagram to represent random variables and continuous, discrete and continuous random variables. One of them is going to be called the CDF function and one is called the PDF function. See it here? We're going to look at that last, all right? But we're still going to illustrate the graph for this question, all right? So I'm showing you that it's right there. All right, so let's continue now. So first thing, Jaden, how do we show that a variable is random? We just said it a while ago in the example above with the table. What did we notice? And you show all the probabilities and it must add up to be 1. That's all. To show that the variable is random, you must just show that everything add up to be 1. That's all. So first thing is them say x is what? What is x? When two dice are thrown. So when we throw some, how many fours can we get? Let's just draw the table from now, right? When we have two dice, how many fours can we get? How many fours can we get? We can get no fours. We can get 1 4 or 2 fours. Very good. Now, to show that it is random, we'll work out the probability for all of these. It must add up to how much, Lamario? Alright, so all of them will add up, these must add up to 1. So first thing, what's the probability of getting no fours? How do you find the probability of getting no fours, Tristan? We just come off a probability. We're fresh off probability. We must know to do this. It's the probability of getting no fours. You have two dice. What's the probability of getting no fours? So, Tristan, look at it. No fours, right? That means that, yes, I have two dice. We know for do this, if I were to give you the sample space and list out all of them, but we don't have time to list out all of them. You know you can get what? You can get 1 1, you can get 1 2, you can get 1 3, you can get 1 4, you can get 1 5, you can get 1 6. Then you can do likewise and get 2 1, 2 2, 2 3. We know so the total must be out of what? 36. Don't? And we're trying to find what's the probability that we got no fours. So like them here would be no fours. 1 1, 1 2, 1 3, 1 5, 1 6, and so forth. What it gonna be, Tristan, out of 36? That's what I'm asking. What it gonna be? 30 out of 36. 30 out of 36. Good. Now what's the probability of getting 1 4 now? Continue, Tristan. What's the probability of getting 1 4? 1 6? 1 4 is 6 out of 36? So you can get 1 and 4, you can get 2 and 4, 3 and 4, 5 and 4, 6 and 4, don't? 4 and 4 would be 2. Would that be? right here. No, something off with your computation because we didn't flip it around. You don't work out this right, no force. Check it again. Because you can always flip them and say you get what now? 4 and 1, 4 and 2, 4 and 3, 4 and 5, and 4 and 6, don't? Isn't that 10? And this now gonna be how much out of 36? 26? What about the one here? You sure it's 26? 26 and 10 and 1 is 37. 25. Alright? 25 right here. Jaden, tell him why it has to be 25. Alright. Yeah, I think what I need to do is show you the sample space. And then now we'll use the formulas to get the answer. So let me show you the sample space. Let me open a blank document. Alright, Tristan, ready now? So let's follow what's happening. So we get the numbers right. Alright? So in this case, right? So see it here with us setting up the dice there. So regular would do them stuff here in add maths, right? Alright, where the option to write? Not getting the option to write. I'm not seeing the option to write on this tab. You're not giving me the option to write. Why not? Alright, let me try this. Oh, see it here. Of all the days the computer acting up. Alright, let me go get some water while it's loading. Alright, sorry about that. Computer just doing whole heap of madness. Alright, so ready. As we were saying, Tristan, with the question, right? Trying to get fours, you can list out everything. You list out everything 1 1, 1 2, 1 3, 1 4, 1 5, and 1 6. Right, Tristan? In 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Good. Then continuing 3 1, 3 3, 3 5, 3 6. Good. Then now 4 1, 4 2, 4 3, 4 4, 4 5, and 4 6. Right? 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. Then finally 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6. Look why it has to be 25 now. Let's check them now with no fours. No fours 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. How much is that, Tristan? So no fours right there is how much? 25 out of 36, right? If you were to work it out now, Jaden might say, why sir, do all of that? The probability of getting no fours, the probability of y equal 0, because they told us to use y as the variable. Getting no fours mean we either get no 4 on the first die times getting no 4 on the second die, don't? Right. So getting no 4 on the first die, we have 5 over 6 times no 4 on the second die, 5 over 6, which is 25 over 6, 25 over 36. This is using independent events. Maybe this is what Jaden did. Right, Jaden? Yeah, exactly. Yes. But I wanted Tristan to see the full picture. That's why I didn't jump straight to this with independent events. So this is what you do with the sample space. This is the computation behind of it. So now the computation behind the probability of getting 1 4. To get 1 4 now, that means I will get 4 upon what? Either we get 4 upon the first die and not on the second, plus we get 4 upon the second die and not on the first. So if we get a 4 upon the first die, it's 1 over 6 times, not a 4 on the second die, 5 over 6, plus not a 4 on the first die times a 4 on the second die. That would work out to be 5 over 36 plus 5 over 36, which is 10 over 36. Right, Tristan? So that is that. Or you could have used a sample space and say, but wait, see it here? 1 4, 1 4, 1 4, 1 4, 1 4, 1 4, 1 4, 1 4, 1 4, and 1 4. You add them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would take long, yeah, but the sample space would take long. So I didn't want you to use a sample space. I wanted you to do the computation and show them. So right here, so to fill out this table, I would have expected you to do the computation and get to the answer, right? So in this case, let's say show that x is random, right? Probably them should have asked it this way. Probably I should have asked it this way. Put this as A and this as B. Because to show that it's random, now you'd show them that the 25 over 36 plus the 10 over 36 plus the 1 over 36, it adds up to be 36 over 36, which is 1. So therefore it is a random variable. Now, we don't really want to focus on this part now, illustrate it on a diagram. I want to do this at the end of the chapter, but illustrating it on a diagram, we usually know what goes on the x and what goes on the y. Which one do you think gonna go on the x? The probability gonna go up on the x or the probability gonna go up on the y? We plot in a graph. Which one usually go on the x and which one go on the y? Independent. So which one is the independent variable? No, Tristan, how you find probability? Frequency of something divided by total frequency. So usually frequency go on the y-axis. So probability, now that going up on the y-axis. And then now the number of fours go on the x-axis. So in this case, the number of fours can either be 0, or the number of fours can be 1, or the number of fours can be 2. Now, when we're working out this, we call this what we call now we call this our PDF function. This is known as a PDF function. So look at it now. So we realize that at the highest was 25 over 36. You're gonna have now 10 over 36. Then you're gonna have 1 over 36. Key thing now, look how to draw them here now. What you gonna do to represent the 25 over 36 for 0? Look what we do, you know. Look what we do. So right at 0, you're going to draw a straight line continuously like this. Then you stop. You draw it from 0 to 1, then you're done. Then now where 1 is, you're going to go to 10 over 36 and you draw a straight line. Then where 2 is, to get 2 fours, that was 1 over 36. So we'll start from there and then we'll continue and we're done. This is what we call our probability distribution diagram. So it shows that right here, so when it is 0, number of 4 is 0, the probability was 25 over 36. And why did we draw this line? We draw the line come over to 1 to show that it's discontinuous. The only reason why we extend the line was to show the discontinuity. We want you to see that it's not a continuous graph. So a lot of people like to call it floor function. So when you go to university, they're going to call this floor function. But this is the probability distribution function right here. Easy, it's very easy, but we'll look more at this at the end. All right, so another example, the most common example they'll give you is these types. When I'm going to give the table and give you an unknown value and say find that unknown value. This is the most frequent type. So Lamar, you take it away now. Find the value of D. How going to do that? Very good. So add them for us now and tell us. Double check, double check. So let's see, 0.3. Oh, yeah, you're right. 0.8, 0.2 is D. Very good. That's correct. All right, now sometimes now them give follow-up questions from the table, right? So I want to scroll out a little bit. We'll find the value of D. So Lamaria, this was yours. Good. You get 0.2. Look at the next part, Lamaria. The whole thing is your question. Them ask you, find the probability n is less than or equal to, n is greater than or equal to -3 but less than 0. How you gonna find that? No, it says are equal to -3 too, so this gets included. Very good. So when you add them, how much you get? Very good. Next one. which is very good. Next one now. Between negative 1 and 1, which is very good. Last part now, the mode. Let's see if we get this one. Very good. Mode is the one with the largest probability, which is negative 1. Because I want, Tristan, you appreciate why it's negative 1? Amon, you good with why it's negative 1? Oh, Amon gone. Yeah, Tristan, you appreciate why it's negative 1? You good with why it's negative 1? All right, cool. So, yes, yes. All right. So now that we appreciate that it's negative 1, I want us to see where this comes from, right? So, again, remember probability would be the number of time it occurred divided by total possibility, right? So if the number of time it occurred over total possibility is the largest, then that means the frequency was also the largest, right? Because the total not gonna change, don't? So very good. Now we had touched on this last week. Well, not last week, week before last week. Expected value. Now, expected value again, it means what? Expected value means it means average. Expected value means what? Average. Expected value means what? Average. So I did give us an example the last time, and I want to just put it back again. So I want to make up an example so we can see it. So let's say I was looking at grades in the class, right? So look at this. Let's say I gave an applied math test, and the grades were how much person gets 70. So this is grades, and this is frequency. 70, 75, 80, 85, 90. And 10 person doing applied maths, right? So let's say 2 person get 70, 2 person get 75, 4 person get 80, 1 person get 85, and one get 90, right? From the 10 people. Now, how do you find the average? How do we find the average again? How do we find bar x? Tristan, how we gonna find bar x? Jaden, tell him how to find bar x. Sum of fx over the sum of f. Follow Tristan? That's how you find mean. That's the formula for mean, don't? Well, this is really intro to statistics. This is measures of central tendency. We're reviewing this to get into the probability distribution. I want you to appreciate where it comes from. So in this case now, we just do 70 times 2 is 140, plus 75 times 2 is 150, 80 times 4 is 320, plus 85 plus 90. Then we divide that by sum of f, add up the frequency is 10. So add up those for me and tell me what we get. Add them for me, please, which is 78.5. Good, 78.5. Now, Tristan, look at this. Maybe now, instead of putting now the frequencies, right? So when you're analyzing data for a company, maybe sometime you can't bother write out how much people, right? So you're working for your big store, and instead of putting that, them say, all right, them say maybe them give you the probability now. So them say the probability 2 out of 10 person would be 20%. So them say 20% get 70, 20% get 75, 80% get 4 out of 10 is 40% get 80, 10% get 85, and 10% get 90, right? So in this case now, there must be a formula that we can use to find the average without having to know the frequencies, don't? So this is the average formula now when you get the probability. The expected value for x is the sum of x times the probability of x equal to x. So all you do is multiply x times its corresponding probability and add them up. So you go 70 times 0.2 plus 75 times 0.2 plus 80 times 0.4 plus 85 times 0.1 plus 90 times 0.1 is the average. Expected value is average. E of x mean average. It's the same as bar x. So put this in our calculator. Got the same thing. So realize that indeed it is true. Alright? I just wanted us to appreciate where the formula come from. So this is the only formula we need to know now. This well, not answer, but formula we need to know. We need to know this expected value of x is x times the probability of x equal to x. So Lamar, you see it here, you worked out this question and you got D was 0.2. So continue now, Lamar, and find the expected value for n. In this case, Lamar, don't say e of x now, because the variable is n, right? So e of n, x. So note that down. So gentlemen, just like if it is x is the variable, we say the mean is bar x. If y is the variable, the mean is bar y. So if n is the variable, the mean is bar n or e of n. Continue now, Lamar. Oh, 1 times 0.2. Yeah, it doesn't do anything. Very good. How much you get? Negative 0. That's where you get to J then? No, negative is fine. Remember, it's negative 3, negative 2, your average always gonna be somewhere in the middle, don't? Yeah, you're right, you're right, you're right. But I just want to make sure it's actually negative 0.9. It could have been negative 0. Maybe 7.6, I don't know. So let's just check it. Plus negative 1 times 0.3 minus 2 times 0.25 minus 3 times 0.1. Yes, you're correct, Mario. Negative 0.9. Very good. And that's all the formula you need to know. The formula again, Tristan, please write it down. Many person, guys, I kind of don't even read the applied math thing them. And hear how them say B people that get this wrong. That's because them now gonna. Yeah, yeah. This is the document, These questions. Yes, the formula is here. Here it is. X times the probability of x equal x. So the expectation of x, or the expected value written as e of x, is given by, see it there? Formula is there. And guys, we are at a significant advantage. So right now I know persons doing applied math from St. Jago. Them have to study on them own. Cornwall is the same thing. Them are do it on them own. Because I know Cornwall maths teacher. And she just doing pure math. No inti, no applied. And persons they are doing inti and applied on their own. And them are gonna make top 10. We can't make them beat we and them not even have no class. That makes sense? No, them are going to the no, as in the teacher doesn't do pure applied or inti there. So we are at an advantage. So I'm going after like the Easter break, I just want to do peer paper ones and paper two. So I'm gonna make sure we get in 45 out of 45 on paper one. SBA may I make sure we get 20 out of 20. So it's really up to you now on the paper two, don't? All up to you on the paper two. Yeah, definitely, yeah. Top five alone. Yeah. So I just want to say we have 10 persons doing applied. We're supposed to say JC 1 to 10. Alright, we're supposed to say JC 1 to 10. But let's see how it goes. That would be amazing. So this one now, Jaden, run through this first now. Expected value of x I was supposed to put here. Sorry, typo. So expected value for x. Well, not the formula. Can just tell me the workout. Very good. Input that in the calculator. 2.91. All right, great. No, I just wanted you to say it a little more pronounced. Great. All right, now the next one is variance. Now, the same way I generated the formula for variance using regular statistics, then go to this formula, we can generate this formula going from statistics. So we can start by writing down the formula for standard for variance. So remember, variance in statistics is sigma squared, and it's equal to, depending on whether it's group data or raw data. Let's say it's raw data, it is xi minus bar x all squared divided by n, or if it's large, n minus 1. Either way, we can use this formula and then generate this formula. But because it have square and then we have to expand and factorize, we can't bother factorize to do the proof. So the same way I did a little proof with the mean, I won't do the little proof with this because that might take too much time. Expand and factorize and stuff. Right? But we're gonna have to know the proof, Jaden and Lamaria, for unit 2. Alright, so next year we'll see it anyway though, but don't need to know it now. We just need to know this formula. Variance is the expected value of x squared minus the expected value all squared. That gives you variance. And then the standard deviation is the square root of the variance. Yeah. Very good, very good. So like this question now. So like this question, to find, first thing we have to do is find the expected value of x squared. Expected value of x squared, well, in this case, expected value of n squared rather. Expected value of n squared would just be, we square n, so negative 3 squared, then we times it by 0.1. Negative 2 squared, then we times it by 0.25 plus negative 1 squared, then we times it by 0.3, 0 squared times 0.15, and then 1 squared times 0.2. All right. And so in this case now, that's what we get. Then now we just work it out. So in that case, we work it out. Put that in the calculator and tell me what we get. What you get when you put in the calculator, Jaden? 2.4? So 2.4. Now, I remember Lamaria got 0.94, the expected value of n, negative 0.9. So in that case, we could just tell him that var n then, remember var n, you need to know this formula, Tristan, it's the expected value of n squared minus the expected value of n all squared. So in that case, the variance would just be 2.4 minus negative 0.9 squared. And you'd put that in your calculator. That would give us 1.59. So that would be the variance. The variance is 1.59. Now, if they wanted the standard deviation of n, we just do what? What will we do to get the standard deviation? Standard deviation of n? Very good. Find the square root of the variance. So we just with the square root of 1.59. And I think that's maybe square root that. I know it was 1.2, but yeah, makes sense. 1.26. That's it. That would be find the expected value for n. We did that. Standard deviation, variance. So Tristan, walk us through this one now. Jaden found the expected value for this one already. The expected value for this was, the scrolling back up, the expected value Jaden got was 2.91. It's the same question here. 2.91. That was the expected value for x. 2.91. Now, let's go ahead and find the variance and then the standard deviation. Tristan, walk us through it now. We need the variance first. We'll find the variance of x, Tristan. Tristan, variance. Tristan here? Yeah, Tristan, ready, variance. All right, now I hear Tristan. All right, Jaden, go through. Yeah, yeah, yeah. Very good. Beautifully said. This is 1 point how much? Good. Then what's the standard deviation? Very good. Very good. Yeah, I would love, yeah, always say approximated. Approximately 1 point. Yes, yes. That's excellent. That's exactly what they're looking for. All right. And this is all you need to know about probability. Repeat? No, you don't have to, but Jaden is saying he would. But I'm saying that is excellent when you write approximately. So it shows the examiner that you understand the difference between the exact value and an approximated or rounded off value. Yeah. So very good. So very good, Jaden. Excellent. So all we're going to do now, we're going to look at a few questions doing probability distribution now. So you realize it very, 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 very easy. Like, see it here, always the same thing them I ask. So this was which year? This was 2017. So let's look at 2017. All right, so we're in module two. Guys, by next week, we're gonna done module two. Imagine that. By next week, we're gonna do what? Done module two. I'm very serious. Exactly. Yeah, and if we want, we could even continue classes online during the holiday break and done module three. So come January, you have Sundays off. Only thing we do then is maybe about March, we start do some papers now. Like full papers, paper two and paper one. We literally can done the syllabus in 5 more weeks. Yeah, yeah, we have an end of term. The the last December 13th. So when we have pure math, we have applied as well that day. But we have to make some time throughout the day when we can do it. Yeah. All right, ready now. So this right here now, Tristan, walk us through it now. Determine the value of P. Tristan, you can hear me? All right, Lamario, go ahead and take it over. Very good. All right, no problem, Tristan. This was supposed to be yours, but because wasn't hearing. All right, no problem. So just adding again for Lamario, 47, 47 and incorrect. Giving it away, giving it away. All right, no problem. So next time you just take out the calculator. 15% plus 22% plus 25% plus 10%. They will subtract from 1. Yes, 0.28. Good. Continue, Lamario. I'll give Tristan the next one then. Expected value. Use the calculator now. That's correct, 1.96. No, 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 no. So the mean, the expected value or the mean is 1.96. That's good. One second. Give me a second. Hello? Mr. Look from when I call you. That's what you say. Me there. Me da call you cause Jake on the day of school yesterday. Oh, you alright though? Yeah. Alright. So, him did this. No, 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 no. Alright, alright. Well, me I gotta have something today because clearly that's not gonna happen. Mm-hmm. Alright, me not say nothing to you tomorrow. Entire week. Okay. Alright, later. Alright, sorry about that. Sorry about that. So in this case now, Lamar, you are good. So the next part now to work out var x. Oh, sorry. You're working out ex squared first. That is how much? Oh, you ignore the zero. Yeah, 1 squared times 0.22 plus. Very good. That's 1. That's 16 times. That is 1.6. That's 2.6. Let's double check that. Good? All right. So what you do next now? So when you subtract, you get 3.8? Oh, oh, oh. Oh, just do the one subtraction, man. 1.5. You realize how easy that is, don't? As Jaden says, this is supposed to be a cape subject, but really and truly it's very easy, don't? Yeah, like look at this. Probability basic. We did this last week. Tree diagram basic. Independent, mutual. What is this I'm asking in question 2? Question 3, I mean, what is this? Easy. These are so easy. This is a cape. An integrated math, the question even word up easier than this. Cape integrated math, yes. Easy. Yeah, cape integrated is easier. Yeah, yeah. Keep improving. No, 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 no. You can, as a pure math student, you can just do integration without going to any class. Just go do the subject. Get it? Yes, yes, you can. No dropping off pure maths. No. Pure math is the truest form of mathematics. The one that challenges you the most. You're worried about the wrong thing right now. All right, so this one now is for 2018. We can give this one to Tristan, then 2019 Jaden. So let's go 2018. All these ask the same thing in number three. Oh, this year, let me see. Pure probability in this one. No expected value, no expected value. This year, binomial distribution or next topic. Oh, so this year they didn't ask any expected. Yeah, they didn't ask it that year, 2018. So I have to go to 2019. All right, so we reached 2019 now, but yeah, paper two. Here's the question now. So this one, Tristan, is yours. Can you read out the question for us? Oh, go on to that, Tristan. You can, but you could work out what they want. But you say you want to start with the table, so start with the table. So them tell you to use the variable x, and down here it says the probability x equal to x. You can either what then? You can either do what? Don't hit the dartboard, or you hit it one time, two times, or three times. Good. But before you complete the table, do the first part and the probability you hit two times. What did they say? Good. So what's the probability him gonna hit two times then? So the probability him hit two times. Look, so look at it now. Can be two and three. So on one throw, him can hit. So look, forget two, that means that out of the three, him can either hit the first one, hit the second one, and miss on the next. Or it could be that him hit the first one, miss the next one, hit the next. Or it can be him hit the first one, or it can be miss the first one, hit the next one, hit the next one, don't? And this would give you add up all of them, then you get the probability that him hit, don't? Two times. But probability him hitting is what? 1 upon 3 times 1 upon 3. So the probability missing is 2 over 3, don't? So that's all we're working out. So the probability x equal to is 1 upon 3 times 1 upon 3 times 2 upon 3 plus hit miss would be 1 upon 3 times 2 upon 3 times 1 upon 3 plus miss then hit is 2 upon 3 times 1 upon 3 times 1 upon 3. I'll do that quick and fast. Multiply the numerators, that's 2 over 27 plus, 2 over 27 plus 2 over 27, which is 6 over 27. You can always simplify it if you want. So in the table, at least you know, say, him hitting twice is 6 over 27, right? And we know, say, him not hitting that not possible, don't? That part is 0. So now hitting it one time. Hitting it one time, what's the probability of him hitting 1 upon 3? Yeah, but remember, hitting it one time would mean him do what? That would mean him either hit one and miss the other two, don't? So we can hit the first one and miss the other two, or him can miss the first one, hit the second one, miss the last one. Or him can do miss the first, miss the second, hit the third, don't? So that would be 1 upon 3 times 2 upon 3 times 2 upon 3. These are the same. So all we do is just add them back again, don't? So this is 4 over, so it's a 12 over 27, right? 12 over 27. Yeah, I want to leave it as 12 over 27, yeah. Now hitting all three now. Hitting all three. Hitting all three is what? 1 upon 3 times 1 upon 3 times 1 upon 3. Oh, you get 9 over 27. Yeah, so let's go. 1 upon 3, 1 upon 3, 1 upon 3. I'm getting what? Hit the first, hit the second, hit the third. That's 1 over 27. So we need, yeah, we need to recompute then, because that is 1 over 27. Make sure we're good. It says 2 upon 27. All right, so hit 1, miss, then miss. That's 4 upon 27. This is 4, this is 20, this is 12. All right, oh, there we go, there we go. This one is not 0, sorry. We didn't look at the case now when him do what? Miss all three. No? You see it now? So the case he miss all three now is 8 over 27. How we get 8 over 27 though? Very good, which is 8 over 27. So that's, alright, so let's put it in 8 over 27. So this would be the, I like this question. This one, instead of just giving you the table and you work it out, that too straightforward, don't? This way the question a little bit nicer. This way it's a little bit nicer and persons more are likely to make mistake. Continue now, Tristan. Evaluate the expected value. Good. You see why I keep the denominator over 27? It's easier this way to add. 12 plus 12 plus 3 all over 27, don't? And that's 20. That's, yeah, that's 1. 27 over 27, which is 1. So that means, we're expected to do what? Hit at least, we're expected to hit 1 out of the 3. So we're expected to hit 1 out of the 3. So we're done. It's just 1. Next thing, chances are, repeat? Hit 1. 1 out of 3, that's 4. That's poor. Yeah, that's poor. That's poor. Okay. No, I noticed I didn't look at the second part now, this part now. So we didn't cover questions like these, so let's get back to that now in the notes. Alright? So let's get back to that. So I didn't put it here. Of course I did. Uh-oh. Where I put it in the notes? I need to edit. I need to edit over the notes. So some things are missing. So this is what we should know. So now the expected value of a constant times the variable x plus b, it can be broken up as the expected value times the expected value of the const of ax plus the expected value of b. But the expected value ax, this works out to be a times the expected value of x. And then the expected value of a constant is just 0. The expected value of a constant is 0. That's all. Now, this is for expected. Oh, I can't believe I just put a differentiating. The expected value of a constant is just a constant. Sorry, guys. I don't know why I'm differentiating. All right. So the expected value of a constant is a constant itself. Think about it. I want us to think about it, right? So if you had a table and the chance of everything occurring was just one flat value, 5, right? Then wouldn't the expected value just be 5? That makes sense? Oh, let me look at a table and show you. So for example, right, everything occurring, let's say everything was occurring at the same frequency, but it was just it's just one flat constant. There's no variable up here. So let's say it is 1, 1, 1, 1, and 1. For this one occurs 0.2. 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 This one occurs 0.2. Then the expected value would just be the constant 1 because a 1 alone up there. Make sense? Yeah, that's all it's saying. So this is what we need to remember. The expected value of ax plus b is equal to a times the expected value of x plus b. This formula we must know. It's in the notes. It's not in the notes, I mean. It should have been in there, so I'm going to have to rewrite that. Then the next one we need to know is when we're finding variance. This is when it gets a little bit different now. The variance of a x plus b, this is equal to a squared times the variance of x plus the variance of b, and the variance of a constant is 0. So this is just a squared var x. That's what we need to know. Now let's look at y. So look at this right here, Jaden. If everything right here is the constant is 1, right? So the expected value is 1. But there's no variation. So of course the variance of a constant must then just be 0 if it's that one constant. You see it? There's no variance here. Nothing don't change. Make sense? Alright, so the only part of it is just that right here the variance of ax is a squared var x. So once we know these two formulas, we're good. Alright, so the variance of ax plus b is equal to a squared var x. That's what we need to memorize. So now let's finish off this past paper. Them want us to calculate this. So them give you the expected value of y. So we just have to tell them this is 3 times the expected value of y plus expected value of 2. Expected value of 2 is just 2. So this is 3 times 3.8 plus 2. We're done. Look how this easy, man. Huh? Oh, no. Oh, no. For this question, the random variable was y. Oh, in our formula, typically though, they use the letter x, don't? So that's why in the formula I use x. No, no, no. The variables can change. It could have been Z, could have been T, it could have been L, but it's just to represent the variable we're dealing with based on the question, right? Yeah. So in this case, it's just 3 times 3.8 plus 2. Boring question. Very easy. 13.4. Now down here now, what's the formula again? So the variance of 3y plus 2, it's going to be 3 squared times the variance of y plus the variance of a constant 2, but the variance of 2 is just 0. The variance of a constant is 0. So it's just 9 times the variance of y, which is 2.16. Punch that in the calculator. And that is 19.44. Easy. Done. Really? This is applied math. This is a CAPE subject. Easy, don't it? Yeah, easy. That's it. So Jaden, your question now, because this was Tristan's 2019. So going to 2020. By the way, you see them thing here that we're learning, Tristan, you see these that we're learning is the same thing you're gonna learn in university when you're doing statistics. You're gonna learn them over. So yeah, they, no, you won't be a statistics major, but when you're doing actuarial science, you're going to do courses called inferential statistics and descriptive statistics. So you're gonna repeat. Actuarial, I started my degree in actuarial science, then I switched because I couldn't manage computer science and I couldn't manage economics. Yeah, you're gonna have to be doing accounting, computer science, economics, and math. Those are the four areas that you major in with actuarial science. I love the accounts and the math, but the econ and the comp sci wasn't. That was definitely not me. So that's great. No, pure math is okay. Pure math will cover the foundation. So once you do pure, you're okay. But doing applied give you even a bigger advantage. Because when you go to university, it's the same thing you're doing over. A matter of fact, I'm going to show some university papers. So, exactly. So, see it there? I'm telling you. Yeah, yeah. So, as I said, the questions, the same thing you're going to learn over about Tristan in first year and second year, right? Only time it changes when you reach third and fourth year, it starts to get a little more advanced. So the maths get advanced third year and fourth year. Everything you do in pure maths and applied maths, that's year one and year two of college. So really and truly, we set the foundation good, college for nice. So you can do anything you know want first year. Second year, because you know say what? You cover the material already. But then third year and fourth year, that's the year for buckle down. No, you don't need to minor in econ. You already can't do enough econ courses. You can do another minor. Yeah. So Jaden, your question, this I know it's really easy for you and you're upset, but no problem. Yeah. Okay. Yeah. Yeah, very good. Next one. Expected value. 2.95. Excellent. Next part now, variance. 10 point how much? One. Very good. Tell them that is to two decimal place. Good. Easy. This is Cape applied math. Boring, don't. Exactly. Well, maybe if they put graph, then maybe like an hour. But really and truly, yeah, easy. It's no stress. It's no stress at all. Like Tristan, look at it. So far, number one to three was supposed to can cakewalk. Number one always start with some what is stratified, what's quota. Once you read over, it's good. They're gonna ask you now to name the sampling method. Number one, easy. Quota sampling. So this is the only one that we would have covered in it's non-random. So it's non-random. So quota sampling, it's almost similar to cluster. All right. We'll review that. Frequency, cumulative frequency, joke. Draw the cumulative frequency joke. Which one would be affected by extreme values joke? Obtained by square of standard deviation joke. Middle 50% of the distribution joke. Work out trim the mean. I just want us to say, oh, number one to three, straightforward. Determine mean, sum of fx over sum of f mode. Describe the shape of the distribution, whether it left skewed or right skewed or it's symmetric. Work out some basic probabilities, then expected values. From number one to number three, we should be getting full marks, really and truly. The only hard question in Unit 1 is going to be number 5, which is linear regression. Everything else easy. Number 6 easy with chi-square distribution. Number 4 easy with binomial distribution. Number 3 easy with probability distributions. Number 1 and 2 easy from statistics. Only hard topic is number 5. Give me a second. Hello, good afternoon. Yeah, yeah, yeah. About Oh, that's for your community service hours? All right, that's nice. That's nice. At Mona, Mona Primary. All right, that's a good experience for community service. That's good. Yeah. All right. I want us to say a university style question because when I give you questions, so for example, when I give you applied math, the 6 weekly test, I don't give you questions that simulate past paper, simulate university. So that's why sometimes Tristan you might say, oh, it look like it's a hard, don't. So I want us to actually do a university question just to gear up for the December test. Because I'm not gonna give you a question like these, don't. It's not. Yeah. You're doing ahead of your time. I'm really giving you university questions. So reality is some. Yeah, I'll give you university questions. So I want you to see these are actually university questions. So this is economics 1005. I don't want to go to the economics. All right, let's look at economics. 1005. We have some problem papers. So I like to give you questions like these, worded a little bit differently. So like this now, this is how I would set up a question. It's same probability distribution, but it's just a little bit different. So Lamar, read this one for us. Very good. So we're going to make the table then. Make the table if the table will help. So x, and we have now the probability of x equal to x. So in that case, Lamario, right, we're going to sub in the x value they say is 1, 2, 3, and 4, don't? When you sub in 1, what we get? When we sub in 1 upon 16, we plug in 2, plug in 3, and then we plug in 4. Notice they all add back to give 1. So now, Lamario, now you can do the question, don't? So now, what's the probability that more than one patient is waiting to see the doctor? Yeah, exactly. 1 minus all of this won't add them up right here. So 1 minus 1 over 6. Yeah, all of those won't add them up. So that's 15 over 60. So that's how I would give the question in a test, right? Because I go to university questions and I simulate some university question. This one, that is true. That is true. It's very limited, but at least with university, they try to make it a little more, you know? Yeah. So number 20. How do the number 20? As the probability there are no exactly, right? None, zero. Now what about 21? Very good. But this time they just word it a little different. Expected value then is 6 over 60. 4 sevens, 28, right? So that's 43, 49, 50 over 16. And 50 over 16 is what? How much? 23.13. So that would be option C there, right? And believe it or not, many persons come to university and fail this course. This course have the highest failure rate because they're not exposed to it from high school. And at university, only learning it in one term. So you can do everything we're learning applied math, them have to learn it in one term, September to December. It is possible because they have two class for the week and all of that, but because they have other subjects doing and other courses, yeah, they probably would have wanted a little more time. Next part, variance. So get the idea though. So realize that look, everything we learn, this question again, basic expected value variance, we're not gonna do it. Realize that this is university, guys. We can do all of them here. Expected value, all of them here we can do. So this is UE though. This is UE. I'm gonna show us a UTech paper. I want to expose it to all the different styles. Let's go UTech. Repeat? No, UE and UTech questions are around about the same. None of them will be harder because at the end of the day they're trying to how I can put it. Remember they're competing universities in Jamaica. They have to be at the same level for us, for our grades to be accepted worldwide. So it's on the same level. So statistics, you take name there stats 2004, but it's the same course. I didn't open stats 2004. I just open. I want to find where did I put the question on paper? Stats 2004. I can open their December test. Let us see. We can do most of it too. Yeah. Oh, thank you. That means we're not going to do binomial distribution. We're going to close off. So I just want you to see a 2016 paper here from, oh, this is a solution paper. Let me look at their actual test. This is a 2016 paper for UTech. So I want you to see that these are, big exam, right? Mathematics and statistics, four pages, 6 questions. We can do all of this. Find mean, median, standard deviation. We can do that. Probability, we can do that. Probability, we can do that. We don't learn Poisson until applied unit 2. So we're going to do this in unit 2 next year. Um, all right, we're about to start confidence interval in module 3. So we can't do this yet. But just wanted to see though that typically is nothing to be frightened about. This is university questions. This linear regression, we're going to do this in module 3 as well. So basically, you can see it's a university. Everything you learn in applied math, Tristan, when you go to university, you going to do this closer than anyone else. You're going to learn about the same thing. You supposed to be the one for even a teacher class. You left JC, where you learn almost everything. I say almost because we're now going to get for the unit 2 because unfortunately. So you have to have a big advantage, Tristan. Big advantage. So you go university, same thing you do over back. Alright? So at least for the maths and statistics course, you're good. You can then spend most of your time focus on the econ, the com sci, and the account. Right? Lots of reading, holy for that, but I mean it's not difficult. It's not difficult. When I started doing econ, why I couldn't bother with it is the whole heap of reading. Couldn't bother. But the graph part of it very easy. Um, learning about basic stuff. It's stuff very relatable to real life, right? Um, while you're looking at, I don't remember what they call the graphs again. Something about when the cost price, for example, women clothing is cheap and they show why it has to be cheap because whole heap of people buying it versus men's clothes expensive because very few people buying it. So we have to find that middle ground balance. And I forgot what they call that graph again. A nice looking curve. Them stuff there, right? So econ, it's easy, but I just couldn't bother with so much reading. But you'll be able to manage. Well, since ComSci is into it, you might want to diversify whatever you're doing. So I would say go a little more in depth in. It's always good to get into some entrepreneurship because at the end of the day, everybody gonna want to own them business down the line, right? So it's always good to delve off into something in that field. If you're already majoring in actuarial science, delve off into something in entrepreneurship. Yes, business administration, something along the business line, right? Yeah, so we're gonna stop here because I want to catch the supermarket for 6. So we didn't get to the binomial. Next week we're going to binomial. Alright? We're going to binomial and normal distribution next week. Alright. Alright. Alright, Jaden. Alright, Mario. See us next week. Alright, next week.